Okay, 1.8 combinations of functions and composition functions. We're going to add, subtract, multiply, divide functions, and then put f into g into f. Okay, so two functions can be combined by operations of addition, subtraction, multiplication, division, just like real numbers. So we have f and we have g. F is the top function, g is the bottom function. So if I take the points, and I add them together, okay? But you have to, like, yeah, we'll add them together. So we have, it'd be -2, 0, -1, 0. Actually, I should write what I'm doing. F plus g of x. And then I would have -2. Actually, that would be 0, -2, correct? 0, -2. And then I would have 1, 1, and 1, 3. And 1, 2, 1. Okay, now I just added the points together. But is that how I would add two things together? I would get different values, wouldn't I? Yeah. So I'm looking. The reason I'm doing this is I wanted to show you that this, I can't just write out the points and say I've added them together, because that doesn't do it, does it? Okay, so when I do these, you add the actual points. And it only lined up on the points we see right here, correct? So at 1, what's 1 plus 3? 4. So that point would be 1, 4. Not 1, 1, and 1, 3. Do you get what's happening?
You don't add the x.
You don't add the x's, you add the what?
Y's.
The y's. So I need to go back. Well, at -0, or -2, 0, we're good because f didn't exist there, did it? No? Okay, but what about -1? We have here and here, yes? Mm-hmm. So it should be -1, and then we would have 0 minus 1, which would be -1. And then at 0, I'm down at -2 here, but I'm up at 1.5 there. So that would be 0, 1/2. No, 0, -1/2. Correct? Up 1/2, down 2 would be 1/2. And then at 2, we would just be 2, 1, because is there anything for g over here? No. So could I do the same thing for subtraction, multiplication, division? Yes. The domain of any arithmetic combination f and g consists of all real numbers that are common. So the domain is what's common. So what is common is -2 in the domain of both f and g. Mm-hmm. No. So does this go anymore? No. And is 2 common in both? So what happens here? So we need to remember that the domain are all real numbers that are common. No. Are we going to have a graph usually? No. We're going to have two equations, and when we add them, we combine like terms. Good? Alex, you good? Oh, I got red on me. Anyway, okay. So add, subtract, product different, or product quotient. We can write it as f plus g of x, or we can write it f of x plus g of x. Either way. Subtraction, we can put it together or we can put it apart. Product, together or apart. Quotient, together or apart. And why can't g equal to 0? Because you can't divide by 0. That's all that ever is, guys. Let me know when you're good.
I'm good.
So find the sum, difference, quotient. So we have f of x is 2x minus 3, g of x is x squared minus 1. So f plus g of x, or just 2x minus 3 plus x squared minus 1. And any like terms we can combine? Okay, so I have x squared plus 2x minus 3. How about 4? Okay, so f minus g. I didn't put parentheses when I added because no signs change, but when I subtract, our sign's going to change. Yes. You need to make sure you have parentheses around what you are subtracting, because what do you need to do with your negative? Distribute it. So that would give me negative x squared plus 2x minus 2. You guys checking my work? Why is it minus 2 now? Plus the 1, right? Negative 3 plus 1. So f of g of x, we have two quantities, correct? So what do you do when you multiply quantities together? You FOIL. So 2x cubed minus 3. You guys do it. Make sure you get the same thing I do. and get 2x cubed minus 3x squared minus 2x plus 3? Alex, you get that?
Mm-hmm.
Okay. So now division is one people are like, oh, what do I do? What do I do? Okay, you're just dividing it, yes?
Mm-hmm.
So you write F over G. Now remember, those are quantities, so until I can factor, I can't reduce, right? The numerator is already factored, and I'm going to put it in parentheses so I don't try to do bad things. And the denominator factors to what? X minus 1, x plus 1. So does anything reduce? Nope. So we're not, that's all you need to do on this. But we also should state that x cannot be what two things? Plus or minus 1. Why can't x be plus or minus 1? Because you can't divide by 0. And if I factored and I'm like, oh, it's a waste of time, I couldn't reduce. But factoring helps me find what it can't be, right? Always state that just domain. Find the following. So I want you to do those 3 on your own.
Oh, they're up there. I was like, where are these?
Right there. F is x minus 4, and G is x squared minus 2x minus 8. I'm going to pause the video. Okay, so you should have x minus 4 over x minus 4, x plus 2. And so you get 1 over x plus 2. And x cannot equal negative 2 and 4. Right? Well, how did I get negative 2 and 4? Where did I get negative 2? Anybody?
Because x minus 4 you reduced out, and then it can't be negative 2.
Right. I set both of these equal to 0, just like we've been doing, right? We've done that before already. Okay, so now I'm going to reverse it, and it's going to reduce, and I'm going to get not 1 over x plus 2, but just what? X plus 2, and x just can't equal 4 that time. Yep, that's okay. That's something. Like I just said on the last slide, every time you have a fraction, what do you need to do? The can't equal. Okay, now what's it say? F divided by G, but what did x turn into? Negative 1. So it's back here at this answer, yes? And so 1 over negative 1 plus 2. So 1 over 1 is 1. Yes?
I just plugged it in
How do you get that?
Plugged it right into here.
I just plugged it into the actual equation.
Well, if you plug it into the actual equation, you should get the same thing.
Yeah.
You should get negative 1 minus 4 over 1 plus 2 minus 8.
Mm-hmm.
So it'd be negative 4 over negative 4, which would be 1.
Negative 5
1
over
plus
negative
2 is 3. And then minus.
Oh, yeah, so it'd be negative 5 over negative 5. Sorry. Still going to be what? 1. Now, if you plugged it in directly, did you forget a negative times a negative was a positive?
No.
Okay, well then why didn't you get 1? Oh, okay.
I subtracted wrong.
Okay. Good. Okay, another way of combining functions is composition. It's like in chemistry, you have compositions of things you mix. The way we write compositions is f of g of x or f composed of g. And I forgot my x. Ooh, that's horrible. I'll just rewrite it underneath. F composed of g of x. And the words we say, that little open circle is not an O, it's not a degree symbol, it's the word composed. So F composed of G. So what that means is I'm putting G into F every time there's an X.
Fog.
So it was F of X. See that? Now it's F of G of X. So that means this X turns into that whole thing.
Squared?
Yep.
Okay.
So F of G of X is X plus 1 quantity squared. Because this whole thing, because this was F of X, yes? And the X turned into G of X. So we're changing every time we see an X into G of X. So if we FOIL that the right way, I'm pretty sure we get X squared plus 2X plus 1. Because that's got to FOIL it out, right? So what if I asked you for G of F of X? So I'm putting F into what? G. So this is F. And I'm putting it in right there. So I would have X squared plus 1. So.
I don't know.
Okay, we'll do another one. I will never write composed of.
That word.
I don't like it because people don't make it a small circle. They make it look like fog. It is just ugly to me. Okay, so what if I ask you for F of X?
Can you do that?
Yeah.
But it's the same thing.
Well, I'm putting itself in, right?
Ew.
So what is F? X squared, right?
Yeah.
So we're going to insert X squared, but then we're going to square it. So when you square, what do you do when you take a power to a power?
You add the powers? Or no, you
Multiply the powers?
It would be the same either way.
Well, only because they're twos. So it'd be X to the
4.
4th.
Strange.
Could I do F of G of F of G
Whoa.
of X?
Ew.
No,
No,
that's me.
you can't stop. I said no.
Okay, so you can.
No means no.
Normally when you do something like that, they have a bunch of different equations, okay? You start on the far right and work your way back. So this says plug G into what? F. Did we do that?
Yeah.
And we got this, didn't we?
Uh-huh.
Okay, and now it says plug that answer into
G.
G. So I need to plug this into G right here. So we're replacing just that with this whole thing. So then it would be X squared, I'm going to put parentheses so you know where you're plugging in, plus 2X plus 1 plus 1.
Yeah.
So 1 plus 1 is?
2.
So you have X squared plus 2X plus 2. Now we are plugging that answer back into F, so then we have to do what with it all? Square it.
That is silly.
Okay, it is silly, but can we do it? Do you get the point of what you're doing?
Yes.
Yes.
Does that help at all, Alex? Okay. So now I have F and I have G, and I want F composed of G. I want G composed of F, and I want G composed of F of -2.
No.
Yes. Well, you just do this, and then you plug in what for X? -2. Okay, F composed of G, so that means I'm putting what function into what function? G into F. Okay, so this in for that. I always put parentheses so I know where I plugged it in. And then I still have a plus 2.
So it would be X squared plus
How about -X squared plus 6?
6.
Yes, or you could write 6 minus not minus a negative. 6 minus x squared. Either one would be correct. Mm-hmm. And now for B, I'm putting F into what? G. You guys want to try it on your own? Give you the hard one. I know. You've not figured this out yet, that I mean.
How do you work that?
Do you see what I did? Now, those parentheses all of are going to be your friends.
Yeah.
Okay, so it says plug F into G, yes?
Wait.
So this whole thing
Whoa.
is going to go in for the X. Just the X.
Oh.
You're replacing just the X. So I have 4 minus, and what's our new X? X plus 2. And then we're going to square it.
Oh, okay.
Oh.
And then you gotta foil it.
Negative.
Yep.
I forgot to do something.
You got to foil it. So you get x squared plus 4x plus 4, and then distribute your negative. Sam, you good? Did you get it? Alex, you get it?
There.
No.
Okay, did you do this first step right?
Yeah.
Okay.
So,
Did you foil this x plus 2? Did you foil that out? Or did you just write x squared plus 4?
I got x squared. That's it.
Okay, but this, the x squared, the x part of it changes into x plus 2. So now
I
you,
need 4x.
because you have to foil this because it's squared. So it'd be x squared, and then it'd be 2x, and 2x would be 4x.
Oh.
And then the 4's reduce out.
Can we do G of F and negative 2 together?
I already did it. You guys just-
So now all we do on the next one is we do this first part, g of f. Did we already do that?
Yeah.
Yeah? So we're just going to plug in what for x now? Negative
just
2.
into the final?
Yeah, guys, remember this is,
Makes it so much
okay,
easier.
just a second. This is f of x. So whatever x changes to, you change it to it. So it's going to be negative 2 squared minus 4 times negative 2. So that'd be negative 4 plus 8,
Yeah.
which would be,
4.
that's some creative math.
8. 16. What's he? 12.
Now, again, our parentheses important.
Mm-hmm.
Yes, because if you don't put your parentheses, you're going to tell me the answer is 4, not negative 4, correct?
Yep. Can you do the cup thing? What cup?
Stop. Stop. Alex, you good?
Yeah.
You sure?
Mm-hmm.
Okay. So now you get to do them all on your own.
No.
Again. Actually, do you want to just do them together?
Yes.
Okay. So f of g of x. Because I should have done the other ones with you. What? Well, then do them on your own. So what's the first one tell me I'm doing?
Hang on, I'm writing down.
Okay.
So for this, can I just put like f parenthesis g parenthesis x parenthesis?
Well, okay, if you want to do f of x. No. You write it like, you can write it like f, you're asking if you can do this.
Yes.
Yes, I don't care, but you need to know they mean the same thing.
Yes, I do.
Okay. So I'm going to put all of g in where?
X.
That one little x.
Mm-hmm.
So it's going to be 2 and then x, but x now is g. So x squared plus 2x minus 1. And then don't forget to plus 1. So then that's going to be 2x squared plus 4x. And then negative 2 plus 1 is negative 1.
That's it?
Mm-hmm.
That's like I was getting there. You're thinking so hard. I was getting there slowly but surely.
I know, it will take time. Okay, now the next one. I have f composed of f of x. So what's going in? F is going to g. So this whole f in for every time you see an x.
Ew. That's ew.
So then it's going to be 2x plus 1 squared plus 2 times 2x plus 1 minus 1. It isn't. It could be worse. Okay, so I have to FOIL the 2x plus 1, yes? So 4x squared plus 4x plus 1. Distribute my 2. So 4x plus 2 minus 1. So 4x squared plus 8x plus 2.
I finished before you.
So what's the last one say to do?
F of negative 4.
Okay. So f of negative 4. So eventually the x's are going to turn into what? Negative 4. So we can do this two ways. I'm going to show you both ways. Okay, so we can put f into f. So f is 2x plus 1, but our x is now 2x plus 1. So I have 2x plus 1 plus 1. So that would give me 4x plus 3. Because it'd be 2 plus 1.
Oh yeah, I accidentally added the 4.
Okay. I'm like, how are you getting 5? I was more concerned how you're getting 5. Okay, so now we change our x into what? Negative 4. So it would be 4 times negative 4 plus 3. So negative 16 plus 3 would be negative 13. Okay, that's one way to do it.
I like that way.
Okay, here's another way to do it. Please quit tipping your chair. I could put negative 4 into f. And then put it back in. So it would be 2 times negative 4 plus 1. So that would be negative 7. And then put negative 7 into 2 times negative 7 plus 1. Which negative 14 plus 1 would be negative 13.
I like the first way.
Um,
I'm going to write that down.
both ways work. Both ways work. I will tell you I use the second way probably more often when I put like it's f composed of g of -7 because it's easier to think about rather than keep putting it back into itself. Does that make sense?
Mm-hmm.
But as long as you show me which way you're doing, I don't care. I used to be a stickler about it. I used to only allow you to do the first way.
Yeah.
At this point in my life, does it really matter? No.
Okay, I have a question.
Yes.
So it says that the assignment that's due is Friday and Monday.
Yes.
So are we working on it on Monday and not today?
No, you're working on it today because if you wait until Monday, what's going to happen, Olive?
You're not.
Mad at us.
What's going to happen if you
Oh.
wait till Monday?
I'm gonna forget it.
Yeah, it's all going to
Fizzle
drain out.
out.
Yeah, it's going to fizzle out. Okay, so I think that's the last slide. So you are working on it, so let's talk about what's happening.